Hi. So basically, this is the code video of basically everything from planning until now. And because when we were working in the planning period, there are a lot of different kind of paths that went nowhere. But now we're in a much more concrete kind of path of what we're going to be doing with this Zeppelin. Pardon me. And basically, this is the main chunk of code that we're working on right now. Um, I will say on the right, it's currently written for temperature. That's what the code we borrowed. That's what it was written for. But Ian Novotny, who's doing a lot of code work on this project and wiring. In fact, he's soldering right now. He has modified this code to work with an accelerometer and with an altimeter. And basically, you're looking at the boot.py here. And what this is saying is the boot.py, it runs every time the Pi receives power and turns on. It doesn't run in a loop, it just runs once. And basically what this is saying is that it's setting a switch on the GP2 pin on the board, and if it's saying, hey, if this is connected to ground, right, if the switch is on, it remounts the storage.remount slash and switch.value, which basically means it goes to a larger thing about how file systems work. But what it means for us is that when we have GP2 connected to ground, and then we turn the Pico on, the Pico can write to itself, but we can't write to the Pico from the computer. Now, when we don't have that connected, what we can do is we can write to the Pico, but the Pico cannot write to itself. And so we have to have a switch like this to be able to go back and forth. And of course, we could wire it in, but that would just not make any sense. And then, oh, pardon me. That boot.py does that. And then you get to your code.py. And the code.py does only work if you, in full capacity, if you have that ground connected to that GP2 pin. And the board LED is just basically being used by this code as a status thing. It goes every second if it's good. It goes every half second if the file system isn't writable, aka if you didn't switch it, and then it goes every quarter second if if the file system is full, which will not happen with our data unless we run it for a very long time, because we're working with 4 values every second, and they're not very large values either. And so yeah, it just blinks it. But over here, what it does is it takes your variable, and then this is written very similar to a print statement, but it's fp.write. And what that does is it writes it to this file. And as you can see, we have temperature.csv, and CSV is a way to store data in a very small way, in a very not easy for humans to read, but easy for machines to read way. And that's temperature.csv. It writes to that, and it just writes the variable, and there it is. And then it flushes it, which basically just doesn't stack a bunch of data on top of itself, and then blinks it and goes through it again and again. What Ian has done is he has modified it to work with these multiple variables, and yeah, and that's most of the code. We're just kind of working through it. We're kind of at the point where we're just looking to really assemble the Zeppelin, and that's our big focus right here, because the code can't really do much if we don't have a Zeppelin to attach the Pico to. And we're also working on, as you can see, may I hold that?
Yeah, you want it? There's only 2 wires.
Okay. As you can see, we're working on soldering this. Obviously, it's not soldered entirely yet.
There's also more room. The reason why there's a bunch of empty spaces, there's more room for motor drivers.
But I will send you his.
And that's a very good point. So we are looking to eventually use motor drivers to be able to control the direction of this Zeppelin, and those motor drivers will potentially be remote controlled, and that introduces a lot of complexity, and so we are leaving room for this thing to grow. But right now, we're just doing what we need because we need it to be as light as possible.